Okay, now that was about spring force, and to just have see one application of the spring force. Have you seen spring balance? There's a hook for this to be hung somewhere, and there's a spring. And again there's a hook for a body to be hung. Now you might have seen some shopkeepers still use this to weigh, and they hung something here and you can see the weight. Actually the spring, there is a indication, there's a scale maintained here. The spring is not visible, there's a hook, and what you see is there is a indicator that goes up and down, and there's a scale, and the spring is calibrated in such a way that the indication is to the weight that is being hung. So whatever the weight be, if you draw the FBD of this weight, there will be some mg and there will be some upward force tension, the spring force. So the spring force will be equal to mg, and if you calibrate the spring such that the spring force, when the spring force is applied, that means the spring is elongated, that this indicator comes to the actual value of the tension. That calibration can be done. So there's a scale mentioned. When this indicator goes up and down, we see what is the value or what is the weight of the body that is hung from the hook. So that's a simple mechanical arrangement. There's not something very much to learn here. This is how the spring balance works. For the spring balance, the thing is, the spring force becomes equal to the weight, to the mass that is hung from there. So suppose we have two spring balances. We'll show the spring balance like this. There's a scale and there are two spring balances in series, and then there's a weight. This is of 10 kg. Okay, now the question is, what will be the reading in the spring balance A and what will be the reading in spring balance B? See, the thing is, the spring balance, there is some tension here that will be equal to 10, corresponding to 10 kg, the tension will be 100 Newton, and that tension will be equal to spring force. And the spring force is calibrated, the spring balance is calibrated that the spring force gives actually the mass, not the weight. Sorry, I said you before that it is calibrated to give you the weight. Weight actually, if the mass is m, weight is m into g. So if a 10 kg mass will have a weight of 100 Newton, weight has a unit of force. So this doesn't show you the weight, it shows you the mass. But the spring force will be equal to the weight. If the 10 kg block is hung, then the weight is 100 Newton and the spring force will be 100 Newton. But the calibration is done to show in the scale 10 kg and not 100 Newton. So that calibration is done there. So the spring balance B will show us 10 kg. And the spring balance A, if the spring balance B is showing 10 kg, then the tension here, because this hook, the spring is attached to this hook. So the tension here is 100 Newton, then the force at this hook to which spring is attached. If the spring is stretched, then the force on both the sides will be equal. Fine, if there is 100 Newton here, the 100 Newton will also be on the other side. So this hook also has 100 Newton and the same 100 Newton is transmitted here. So the same 100 Newton will be the force in this spring. So the same mass will be shown in the upper spring as well. So they're not going to show 5 kg and 5 kg, they both are going to show 10 kg of mass. Okay. Now similarly, suppose from a platform, a mass of 2 kg and 2 kg are hung through both sides of a spring balance. Now the question is, how much of the mass is the spring balance going to show? what will be the reading of the spring balance? 2 kg, 1 kg, 4 kg, what? So from the analysis, you see that the tension here would be 20 Newton, the tension here would be 20 Newton, the tension on both sides of the spring is 20 Newton, that means the tension in the spring is 20 Newton. So the calibration would be such that the reading of the spring balance will show 2 kg. So the reading of this spring balance will be 2 kg. Okay? Okay, then very similar on the same line of questioning, let me ask you this. This is a spring balance. On the other side, we have a mass of 10 kg. And the question is, the whole system is frictionless, this surface is frictionless, and this is fixed, the wedge is fixed. So the question is, this is 5 kg, 10 kg, a spring balance. What will be the weight, what will be the mass shown by the spring balance? The mass shown by the spring balance would be, tell me how much would be 5 kg? Are you getting this? Okay, so that's enough. Now rest, there are many problems there out in the exercise that you will be solving and you will be having more practice.